All right, everybody. We are now moving on to the final frontier here in college algebra, talking about systems of linear equations. So we'll start with some systems of linear equations in two variables and then work our way upward. So what is a system of linear equations? Well, it's really just a collection of two or more linear equations, which we'll write as a times x plus b times y equals to c. So A, B, and C are going to be some real numbers, and X and Y are the variables here. And so a solution to a system of equations is going to be a pair X comma Y. So that represents like a point in the plane that satisfies all the equations in the system of linear equations at the same time. So just to see some examples here of a solution and a non-solution, let's look to the following. So they give us here a system of two equations, 5x minus y equals to 11, and x plus y equals to 7. And they ask us to determine if the pair x equals 3, y equals 4 is a solution to this system. So we will place x equals 3 in for x everywhere we see x, and we'll place 4 in for y everywhere we see y. And then the first equation becomes 5 times 3 minus 4, which is 15 minus 4, which is 11 as predicted. Okay, and then if we put in the second equation, we get 3 plus 4, which is 7, as they predicted there. So here, the pair 3 comma 4 is a solution to this system of linear equations. In the next example, they give us the system of linear equations 2x plus 3y equals to minus 3, and x minus 8y equals to minus 5. And they ask us to determine if the pair minus 3 comma 1 is a solution to this system. Well, we'll place minus 3 in for x and 1 in for y and see what happens. For the first equation, we get 2 times minus 3 plus 3 times 1, which is minus 6 plus 3, which is, minus 3, as they expected. But for the second equation here, we get minus 3 minus 8 times 1, which is minus 11. That is not equal to minus 5, as they'd wanted. So this pair does not solve both equations at the same time, so it is not a solution to the system of equations. Okay, and so what is the meaning of this really? So we've seen that these pairs, they're really equations of lines in a sense. They just aren't written in the slope-intercept form. But we could rearrange any one of these equations to be something of the form y equals to mx plus b. So it is really, each one of these equations is really has graph that is a line. And if we have two or more lines in the plane, then a solution to the sort of corresponding system of equations is really just a point of intersection of those two lines. So notice here, we have this system of equations 2x minus y equals to 1, and y equals to minus 1/2 x plus 4. On the graph here, it looks like the x value 2 and the y value 3 give us a place where these two lines meet. Okay, so this one here is the line minus 1/2 x plus 4, or y equals to minus 1/2 x plus 4. And this other line here is the line 2x minus y equals to 1. You can say that that one is really y equals to 2x minus 1, having slope 2 and y-intercept minus 1. And so if you plug in 2 and 3 to these two equations, x is 2 and y is 3, you'll get what? 2 times 2 minus 3, which is 1. And 3 equals to minus 1/2 times 2 plus 4. Good. Okay. The next, what seems to be pair of equations here, turns out to have graph that's just one single line. Well, what's going on there? The first line is 3x minus y equals to 2. Rather, the line y equals to 3x minus 2, so it has slope 3 and y-intercept -2, as we can see from the picture here. And the other line is 6x minus 2y equals to 4. Well, what happens if we divide this whole equation by 2? We get the first one back. So this one is no different from the first one. And so if we were to simplify, this would become what? 2y equals to 6x minus 4, which then we can divide by 2 and get the same thing. Y is 3x minus 2. Okay, so these are the same line. So really, the set of x and y that are the same, that are solutions for both of these equations, are really just all the pairs for every x value. We then have y equals to 3x minus 2. So we get here an infinite number of solutions. Okay, in this last example here, it looks like we have two lines with the same slope, but with different y-intercepts. Okay, so these are two parallel lines then, and since they are not the same line, they will not intersect since they are parallel. So these two lines never intersect each other, so there will be no solution to this system of equations. Okay, there is no place where these two lines meet. Okay, so now how do we solve systems of equations? Well, one method that we have is what's called substitution. And so substitution is a method wherein we take one of the equations and sort of solve for one variable in terms of the other, and then plug that expression into the second equation to then solve for one of the variables at hand and plug that solution back into the first one. Kind of this tennis match of solving equations bit by bit. But this method, I think, is actually surprisingly useful in this course. So we will definitely want to keep using this one anytime that we can. So they give us here the system of equations where the first equation is x plus 3y equals to 11. And the second is 4x minus y equals to 18. And notice just right off the bat, I can take the first equation and solve for x in terms of y. And in particular, x equals to 11 minus 3y. Now I have a nice expression for x. I'll plug it into the second equation. That is 4x minus y equals 18. Well, now I'll plug in for x, 11 minus 3y. So that gives me 4 times the quantity, 11 minus 3y, then minus y equals to 18. I'll multiply the 4 through, and I get 44 minus 12y minus y equals to 18. That gives me 44 minus 13y equals to 18. Okay, I can subtract 18 from both sides and get 26 minus 13y equals to 0. And I can add 13y to both sides and get 26 is 13y. And now I can divide both sides by 13 and get y equals to 2. And now I know what y is, so I can go back and plug it into the expression I have for x to find out what x is. So if y equals to 2, then x must be 11 minus 3 times 2, which is 5. And thus the solution here is x equals 5, y equals 2. Okay, and there is another method by which we will solve systems of equations that you may like better, but I don't know. I think substitution is about as good as it gets most of the time. And we'll save this other method for the next video. So we'll see you then.